الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Okay, so hello everyone, Assalamu alaikum, and welcome to another session, part of the MENA DD series. As always, my name is Taha Rehah. I'm an expert machine learning trainer at Bamboo Geeks. I'm so happy and so glad to be with you on another session on the track of data pipelines on GCP. So basically, on last session, we have started our first session about Airflow. We talked about what is Airflow, how to manage Airflow, why does Airflow exist, and we saw an example on Airflow on GCP, and we mentioned that GCP has its own version of Apache Airflow, which is called Cloud Composer. And in this second session, we are going to be focusing on the Cloud Composer, having a demo on it, try to create an environment, test a Python file DAG, and see how all of this is being working. Then inshallah, on upcoming next sessions, we are going to be working on hands-on projects like deploying, managing, continuous training, continuous development, and or even training the models and inferencing them on the GCP, and managing the whole data pipeline, just like using the Cloud Composer and some other cloud services that we are going to be introducing along the track, inshallah. So on the agenda of today's session, we are going to be talking about why we use Apache Airflow, just like a refresher, and why we need even Cloud Composer, and what's the difference between the both of them. Get some core concepts as a refresher, so the concepts of Apache Airflow Web Server, Apache Airflow Scheduler, operators, hooks, sensors, etc. Then see the structure of a one Python direct acyclic graph, how we can write our first hello world of one specific DAG using Python. Then we are going to get in a demo on Cloud Composer, just like using Quick Labs, to see how all of this is being managed. So yeah, let's start. Let me just check this here. Okay, great. So let's start. Basically, Apache Airflow is one of sorry, I don't know what is my yeah, sorry. Okay, so Apache Airflow, as we have been seeing on the past session, is very popular open source tool that is being developed by Airbnb, backed up by Airbnb, to first of all offer, schedule, and monitor workflows. So basically, with using Apache Airflow, since it's a very top level Apache project, it's well maintained, and it can offer us creating workflows, scheduling workflows, and monitoring them. Cloud Composer, or Google Cloud Composer, is being built on the top of the project Apache Airflow with just some modifications and some easy to use tools or options that they're going to be very helpful to any developer who want to start with data pipelines on GCP. Why we even need to use Apache Airflow? First of all, it's open source. It's open source and it's easy to use since it handles Python. Like most of the workflow management tools or libraries, they are not handling the open source. They are not handling the Python language, and we all know that Python is very simple. So it's an advantage. It's a very big advantage of Apache Airflow to use it with Python. Secondly, it's well established. It has well-established interfaces, either on the command line interface or on the web server. So you can use Airflow as a server, as its own managed server on a virtual machine. So it's going to be very good. It does offer a very great command line interface. Also, it does offer a very great UI that you can use or handle. It's what we call the Apache web server. Third, it's flexible, and dependency management with like with retries are like dependency management is also like very good, so we can like handle it very easily. It contains a very big and very rich library of connectors. We are going to be seeing now when handling Cloud Composer. I'm going to show you like some of the few connectors that we are going to be using. You are going to see that it's like it contains plenty of connectors, of operators, of hooks that they can let you integrate with any technology on your mind. Like you can integrate with database, with cloud providers. You can integrate with anything like anything that can use IT. It can be integrated with Apache Airflow. So that's also one of its big advantages. It also has its own active community support. So also that's always a big point to check when using a technology. But however, all of this we all know it from the past session. But however, the setup, the management, the login, the debugging can like be on Airflow can be very time consuming and can be very tedious. So basically, that's like one of the very big limitations of Airflow, and like many developers are making are getting like a lot of complaints about it, is that like the setup, the configuration, and also the debugging of Apache Airflow errors can be sometimes very time consuming and very like mind cracking to solve. That's why Google introduced the Cloud Composer service, which is like a fully managed implementation of Apache Airflow on GCP or on Google Cloud Platform. It's like contains its own web server, its own database server, and its own application server or scheduler, which is offered by Google and managed by Google. So basically, you as a developer using the Cloud Composer service, you don't have to manage any of these. You don't have to manage deployment, how to set up the web server, how to set up the database, etc., etc. No, you just like create an environment, you deploy on it the version of Airflow. Just like choose the version of Airflow that you want to use, either Apache Airflow 1 or 2. Then like you have Airflow installed, you have an endpoint to use Airflow on it. You have also a database that is running on the background. You have the scheduler running. So basically it's fully managed, and like there is no mind cracking or time waste on the development or on the deployment of your Apache Airflow in any of other techniques like virtual machines or something like this. So basically it's fully managed, and it does like let you author end-to-end workflows on Google Cloud. So when you have Apache Airflow hosted on Google Cloud, basically you have access to all the Google Cloud services that they can integrate very easily. So you can build using the Cloud Composer. You can build a very easily an end-to-end workflow. Unlike like when Apache Airflow is being developed on a normal or classical technique out of the Google Cloud environment, it's going to be a little bit confusing, and you are going to be needing more operators and more hooks. But with the Cloud Composer, it's easy here to do. Obviously, it does integrate with all the services of Google, citing the BigQuery, the cloud storage, the Vertex AI, etc., etc. So basically, you can integrate with any of them. Each Google Cloud service has its own operator. So it's like heaven here with the services of Google. Also, Google does take care of the security of your workflows across like something that we call on the GCP access management, integrity and access management, or IAM tools. So basically, we all know, or anyone that uses the GCP, you know that IAM tools, like what we call identity and access management, are very powerful, and they provide very high level of security. So with Cloud Composer, you have Apache Airflow, the own Apache Airflow security, plus the identity and access management of Google Cloud, which is going to be very great. Then, like the fourth point is that you have an infrastructure fully managed by Google, which means like that's as I was saying, you don't have to deal with virtual machines, you don't have to deal with Linux versions, operating system versions, you don't need to deal with networking issues, you don't have to deal with database issues. Like you have a very whole infrastructure fully managed by Google. Also, like exploring Cloud Composer and the Airflow logs, you can explore them through the Cloud Operations login and monitoring. That's a thing that it's not very easy to do when you deploy Airflow on a simple virtual machine, since you need external tools like Sentry or something like this to see or to manage to monitor your logs of Airflow. I'm going to show you very quick the interface of Cloud Composer and operations monitoring. It's something that is very, very interesting. Okay, now we can go directly to like a very quick refresher about the concepts of Airflow. Basically, first thing to talk about is the two main components, which are the Airflow web server and the Airflow scheduler. So we have Airflow scheduler and Airflow web server. Those are the main components. We also have Airflow workers, but they are like part of the scheduler. So basically, on the web server, it's the UI. It's the platform that is offering everything to manage. So like using the UI or using the Airflow web server, we can monitor our DAGs. We can see them on the graph view, on the tree view. We can create accounts. We can like trigger automatically or manually our DAGs, etc., etc. The Airflow scheduler is the heart of Airflow. So basically, the Airflow scheduler is the one responsible of instantiating your DAGs. So he's just like scheduler is going to be like creating an instance of the DAG, then being responsible of sending it to the workers to execute the tasks. Also, the scheduler is going to be also responsible of by its definition and by its name, is going to be scheduling when like the tasks need to be sent to the workers to be executed. So the Airflow is the manager, is the big boss. The scheduler is the big boss of the Airflow ecosystem. We have the web server for managing the UI. We have the workers for executing the tasks, and we have between them the scheduler who is going to be responsible of communicating. Then also we have a meta store, what we call a meta store. It's a store of database. It can be an SQLite database. It can be a Postgres. It can be a MySQL, and then any like normal database where like all the logins and all the communication is going to be happening through that database or that meta store database. I was talking about DAGs, tasks, etc. So like the third concept that you need guys to always remember about Airflow is the directed acyclic graphs, which is like just a term to say that what is a directed acyclic graph. Directed acyclic graph is just like a graph that cannot enclose a loop by its end. So there is no loops on our DAGs. Our DAGs needs to be sequential, needs to never have loops, and that's a very high level criteria that we need to always pay attention to it when designing our DAGs. Each DAG contains tasks. So as you can see here on the legend, rectangle is a task node. Which is a task? A task is just like a step on the algorithm. So just like think about the DAGs as a whole algorithm. Each algorithm has its own steps. Those steps are called tasks. And the arrows between the tasks are task dependency. So in Airflow or in DAGs, we cannot like those arrows are one direction, so we can never like go back on the other direction. Also, basically the second task or the task after the dependencies on the tasks is being based on the fact of not having or like being based on the fact of waiting for the task before to execute itself. So like it's very high, there is high dependency here. We can deactivate it or deactivate it, but mostly it's going to be waiting for here, in this case, waiting for fetching the weather forecast, then like cleaning it, then joining it with other data sets. Another thing also with DAGs is they can run in parallel. So we can run tasks in parallel. It's not like we are not obliged to run like tasks in one sequence. We can run tasks in parallel like those 4 tasks. So we can fetch data from this source and clean it. In parallel, we can fetch data from another source and also clean it. Then we can join 2 of them and continue on our DAG or on our schema or our Airflow pipeline, data pipeline. So a task, now we were mentioning the web server, the scheduler, the tasks, the DAG, and then the task. Like, so this is the hierarchy of things that like you need to remember. So web server, scheduler, workers, tasks. Now inside each task we have an operator or a hook, or mostly it's an operator. So just like a task is an instance of an operator, and DAG DAG is composed of many tasks, so which means like many instances of many different operators. What is an operator? As I was saying, it's an instance of a task, and also we can think about the operator as a wrapper around like each unit or each task is going to be defined to do some action. So let's assume that we want to write a function in Python that is going to be I don't know, calculating 2 times 2 and returning the output, or calculating x times y and returning for us the response or the output. So that's a normal Python multiplication function. We can like set this function as a task. So we can say here that in this task we are going to be multiplying x and y. This is what we call like this can be only possible by using the Python operator. So it's just like a wrapper, an encapsulation thing that we encapsulate inside our code. So I was given an example of Python. Also, there are plenty of operators, like each one specific for each service. So we have the Postgres operator. We have Postgres operator for like managing database, connection database and insertion, etc. We have GCP or BigQuery to GCS, which is like BigQuery to Google Cloud Storage operator. We have Cloud Storage operator. We have WASP operator. So we have one operator for one specific action. That's the idea behind Airflow, and that's also one of the power of Airflow, because when having like an operator, like not having packages or having libraries, we are dealing with operators. Those operators are specific to do one specific task. That's like the logic or the abstraction that Airflow is providing to developers to think about each task as its own dependency or its own way. Also, we can create our own operators. So we can create a MENA-DD operator, an example. That operator is going to be fetching videos from YouTube of MENA-DD of one specific topic and like sending them to me. So I can do this. How? By inheriting from the base operator. The base operator is the godfather of any operator. We can say that it's between parentheses the godfather. So basically, we can inherit from it and then like give it a name and specify what that operator is going to be doing, what type of action, and what type of parameter or arguments is expecting, and what type of output is given to us. It's like defining a class that is going to be doing one specific task and interacting with one specific service. Either it's a database, either it's a machine learning thing, either it's a data engineering thing, etc., etc. And to get to know those operators, there is on the website of Apache Airflow. So it's just like airflow.apache.org/integration. You can have integrations with public cloud providers. Here, like we are talking about GCP, we can see here that we have integration with BigQuery. We have the BigQuery operators here. We also have, like inside the BigQuery operators, we have many operators. So we have the BigQuery, the main one, the BigQuery check operator, the create empty table operator, delete dataset operator. So you can see that, but by its name, each operator is doing one specific thing. So this operator is emptying a specific table. This operator is like creating external table. This one is deleting a data set. This one is sending from BigQuery to BigQuery. This one is sending from BigQuery to cloud storage. So basically, like you get the idea of an operator. An operator is specific for doing one task and it's done, like nothing more. Also, like another example for the cloud machine learning engine. So we have operators for machine learning engine, batch prediction operator, for model operator, training operator, versioning operator. So basically, we have an operator for like any specific task. Yeah, so next one. Okay, so here also we will have the same for any other public provider. Either it's Microsoft Azure, either it's Amazon Web Services, either it's Databricks, either it's Google Cloud Platform. The fourth or the fifth on the list is the Airflow hooks, or are the Airflow hooks. Hooks are like under operators. So we have the API or the system that is going to be provided like Postgres. Then we have the hook. Then we have the operator. The operator is responsible of doing one specific task, deleting a table, inserting a table, making some certain queries, etc., etc. But the hook is responsible of connecting with that service. Is responsible of like making that connection. So we can think as of the operator as the public thing that is going to be interacting with the code, etc., etc. Then the hook is the one of just like assuring that connection and assuring that that service can be integrable by Airflow. So before having operators, we have hooks. The hook is the one is going to be integrating even that service on the pipeline. It's like leveraging. Like let's imagine that we have a service X that is not yet being integrated with Airflow. So in order to integrate that service with Airflow, we need to create a hook for it. So that hook is going to be just like doing the first abstraction layer. Then we have the operators who are going to be using under the hooks. So it's just like the name where hook came. It's just like because it operates under the hook, and it gives us like the ability to work and to connect, to integrate with many new services. So let me see if any questions are on the chat before like moving on. Basically, yeah, we don't have any question now, but if you have guys questions about what's happening now, please just ask them all along the session. Okay, so I think I can continue. Okay, let me go back here. Okay, now we are going to be seeing how DAG on Airflow can be implemented and can be like curated. So the very first basic thing to do is to make the imports, obviously. So we install Airflow. Like the installation of Airflow is very basic. If you want to install it on like your local machine, you just set up a virtual environment. You just like pipe install Airflow. Obviously, it's going to be installed in the version number 2. Then tada, you have Airflow installed on your machine as a CLI. If you want the web server and you want the scheduler, like some other steps can occur, but it's obvious. It's an obvious thing to do. Okay, so from Airflow module, we are going to be importing the DAG class, which is like our main thing, our very first thing to start with, which is a DAG class. Then inside Airflow, we have the operators module, and like each, as I was saying, each service has its own operators. So here we are importing from Python operators. We are importing the Python operator. And here, like from datetime, we are going to be importing datetime, just like to convert. Why I'm going to show you now why we need datetime. Because like the very first line to do is creating a DAG instance. Each DAG instance has its unique DAG ID. So we need to give it a unique ID, which is like the whole name of the DAG. I was saying that the DAG is a sequence of tasks. So one specific DAG can have or need to have at least one task. We cannot define a DAG without tasks. But before defining the task, we need to give it an ID, give it a start date, when it needs to be started, because as I was saying, that we have the Airflow scheduler, and the Airflow scheduler is going to take this variable, the content of the start date, and going to be running the DAG at this time, or like either here we have the schedule interval, which is like can be hourly, can be daily, can be monthly, can be weekly, etc. So, or can be like after 5 minutes or after 5 hours, or like custom thing. So the scheduler is going to be taking the start date plus the schedule interval, and then he's going to be running the DAG accordingly. Catch up equal false, which means like here we are not going to be rerunning or catching up anything from this DAG. We are just going to be running it, and it's done. So we instantiate, or we create an instance of the DAG. Then inside the DAG, we define our very first task, which is going to be an instance of the Python operator. So Python operator is going also to take a task ID, which needs to be unique among all the tasks. So our task ID here is hello world. We have task ID. Then we have our Python callable, which is a parameter to call a function. So we're going to be defining our function and call it here on the Python operator. So we go and we define our function here up before creating the instance of the DAG. So our function, what does our function do? It just like prints hello world. like as simply as this. So we pass the name of our function to the Python callable argument, which means that like when I'm going to be triggering this DAG, I'm going to be running this task. I'm going to be also inside this task running this function. So that's the AR key. And here I need to specify the order of the execution of the task. So here I only have one task, because I have only one task, I'm going only to write its name here. But if I have many tasks, I need to write task one, then like use the bit shift operators. I'm going to show you what is bit shift operator in a very quick slide. Bit shift operator to define the order of the execution of the tasks. Either it needs to be task one, then task two, or task two, then task one, and task one needs to wait for task five to run. So we just like define that sequence using the bit shift operators, or like we can define them directly on the code. Okay, so like enough theory. We have been speaking a lot about theory. We can now go directly to practice. You're going to be having a link on the chat right now, which this link is going to be leading you to a Google Quick Labs or Cloud Skill Boost quest. Let me open it here for you. I'll be trying to follow this. I'm going to be trying following this lab. Obviously, I'm not going to be starting it just like because I'm going to be using my own collab, my own Google Cloud account. But here the idea is to show you how to create your own like Cloud Composer environment, set it up, open Airflow, like import or export DAG, a very hello world DAG on it, then like run it and see like that things are working. So the first thing on GCP to go on is to go to like here more products. Then you go to analytics. Okay, so operations, CI/CD, yeah, analytics. Here we have Composer. So we click on Composer. You can see here that I already have my own environments, but basically if your account is new, you are going to be asked to to enable the API of the Composer. So Composer API, yeah, this one. So if the Composer API is not enabled on your account, you need to like click enable here. If it's enabled, you're going to be having this interface with zero environment. Now, how to create an environment is just like simply by hitting here create. So basically you have two options. Either like you create version 1 of Apache Airflow. So here Composer 1 is the older or the oldest version of the Composer. Here you can create like an environment using this version, or create the version 2, which supports auto-scaling. Which is auto-scaling is the fact of when you have a very high load of like requests and very high or very busy traffic, like Composer, Google Cloud Composer is going to be scaling automatically, creating more pods for you, creating more available clusters for you. So that's like a Kubernetes concept, because under the hood, Composer is like running Airflow on Kubernetes. For people who do not know Kubernetes, what is Kubernetes? Kubernetes is just like a managing service or tool for managing containers. Containers are just like boxes where we do make our code inside it, which is like each container do not know what other container contains or what the other box do have, and they all run on the same operating system. That's what we call that's very quick. We have an operating system. On the top of it, we have containers. On the top, we have Kubernetes managing those containers. Oh, that's the idea here behind what's like under the hook of Composer. So for my case, I'm going to be choosing Composer 2. Okay, let me check here. Okay, so here we need to specify the name of our environment. So we can call it MENA DB GCP Composer. We choose the location. So basically, it's going to be taking a lot of time if you choose a region that is very far away than where you live. So basically, if you are on the MENA region, I think the most like close data center of Google is on Europe. So either you can select Europe Central or Europe West, or you can still like select US Central, US East, but it's going to be taking more time or long time. So basically, for just like time purposes, we can use your Europe Central. So here we specify the Composer version, which is like here, Composer 2 with Airflow 2.2.5, which is the latest Airflow version, or you can still use the Airflow 2.1.4, which is the previous one. Here, where you choose like the infrastructure that is going to be managed by Google. So it's, as I was telling you, that the Airflow, the Composer, is going to be running on Kubernetes, and those Kubernetes is just like machines, like PCs. So basically, they do have memory, they do have storage, they do have CPUs or GPUs. Basically, that's the idea. And here you have like plenty of choices. Either you can use the smallest packages provided by Google, which contains on the scheduler part contains like half CPU, 1.8 gigabytes of memory, and 1 gigabyte of storage. And we have only one scheduler. For the web server, we have also half the CPU, 1.8 and 1 gigabyte. So for the web server, the worker, and the scheduler, they all share the same configuration. And we have only one scheduler. A number of workers is going to be automatically auto-scaling from between 1 and 3. So this is the smallest environment. For the medium one, we are scaling from half CPU to 2 CPU and to 7.8 gigabytes of memory and to 5 gigabytes of storage. So this is like even a little bit larger. Then we have the large package, which contains 4 CPUs, 15 gigabytes of memory, and 10 gigabytes of storage. Or you can use your custom. So here you can define how many CPUs you want. Depends on the need of your data pipeline. If your data pipeline is very heavy, you can still choose 16 vCPU. You can choose like 80 gigabytes of memory and choose like 10 gigabytes here of storage. So you can define different things for scheduler, different also configuration for the web server, and different one for the worker. So basically, me, I'm going to be going for the smallest one. Here you can configure the network, so like the virtual network, etc., etc. And here define just like the deployment or the maintenance specifications. So for just like time saving operations, I'm not going to be clicking create because it's going to be taking a lot of time, but I already have previous created environments. So like I'm going to be entering this one, the MENA environment. So here, this is the first dashboard of the Composer. But before even digging into the dashboard, you can see here on this line, you have the Airflow web server link. You have the DAGs list, which is going to be showing you how many DAGs we do have in our Airflow. And you have the DAGs folder, which is going to be showing you the files, the .py file, .py files of your DAGs. And here, if you want to access Airflow, so when your environment is being deployed, you can directly click here, and it's going to be opening Airflow for you. So here, Airflow is going to be opened. The web server, the Airflow web server, as you can see here. So I have the Airflow web server opened for me. Everything is working good. Everything looks fine. Google or the Composer already provide us with a sample Airflow DAG, which does just like an echo. I can enter just like by clicking here. You can see here on the tree view how many successful or failed run tasks that I did run. Or you can see on the graph view how many tasks I do have on my graph, on my DAG. I only have one task called echo. If I want to see the code, I can just like click here on the code. And I can see that here, like Airflow, your web server is showing me like what is the code that is under the hook of this DAG. So you can see, or we can see that here we are using the bash operator. The bash operator is like the Python operator. Just like Python operator is running Python, bash operator is running bash, which is like obvious. So here we are creating an instance of the DAG. Yeah, we are like giving it an ID, giving it default arguments. a description, a scheduling interval, and DAG run timeout like variable or constant. Then we like create an instance of the bash operator. Here we give it like the task, the bash command that we want to run. Here we just like want to run echo test. Then the DAG under like which like does belong to, depends on past and priority ways. Okay, so if we wanna run this task and see the output, we just like simply can trigger our DAG manually by clicking here, trigger DAG. We can see that the DAG here is being loaded, then running, then executed. Okay, so you can see here when it's queued, running, success or failed, up for retry, up for schedule. So we have a color palette here that is a little bit, that is like very, very rich. So if you want to see the output of the DAG or of the task, you can just like go and click on any of the successful like tries, click on it, go to log. When you go to log, you're going to be seeing here the log of the run of your DAG. So since our DAG is very small, we can just like go and look for the output, which is here. You can see our output is test. And the bash command was echo test. So you can see that bash -c echo test, which is like the command that was run on the terminal. Then we have the output of the command, which is test, which means that like everything was running successfully and our airflow is configured very well and we can start like working on it. If we go back to the environment, then we click on MENA environment. So you can see here the dashboard of the monitoring. We can see the health of our airflow. Are the workers going or doing well? Same for the SQL database, same for the web server, schedulers, etc. So I didn't mention or I forgot about mentioning that in Cloud Composer we don't have the ability to control which type of database we can use, because Airflow can give us the ability to use Postgres, SQL, SQLite, etc. But Cloud Composer or Google choose like the SQL database, which is going to be it's a MySQL database, so we cannot change it. It's not an option to change it. We need to deal with it, but it's just like a metastore dataset. Also, it does create a folder, a bucket, a Google Cloud Storage bucket, where we can store our DAG folder, our DAG files, which is going to be also helpful. So you can see here on the logs what's happening. Okay, so here for the scheduler also we can see under the hook what's happening. Here for the DAGs, you can see that I have one DAG that was run successfully 11 times. I can go up here. Okay. So you can see here, like even Cloud Composer is offering nearly same interface as the Airflow in the web server, where I can see like all my runs. I can like see the task ID, which type of operator, the duration, how many tries I did, the DAG run ID, etc. So like, to be honest, this is not easy to do when you deploy Airflow with your own own classical method. Sorry. So here you have the diagram. Which is like equivalent to the graph view, which is great. You have also the code. You can see the code and the thing here that you can edit it. So you can open it you can close the read-only mode. You can overwrite it and make changes on it. What else? Here we have environment configuration. So here we have where the DAGs folder belong to, because we're going to be needing this. It's a bucket where we do have where it's going to be hosting all of our DAGs. We have the Airflow Web UI, the link, the URL, the configuration, etc. So basically here we have many things that we can still manage. So discovering a little bit the Airflow Web Server UI, we can click here, the main one. Okay, so here you're supposed to have the list of your DAGs. We are going to be inserting a new DAG here to run it. But before, here you can go to admin. Then here you can see we have a list of choices. Here we can define global variables that Airflow can use when running DAGs. So one also of the best advantages of Airflow is that like it can takes global environment variables even if you are not being deployed on like virtual or simple Linux system or OS system. So you can define your own global variables here. We can do configurations, and the best thing here is that you can create connections. So here we have many types of connections that we can specify. So let me just like click here where the hooks comes to help. So basically here we are going to find that we have many services that we can integrate or we can create connection with it. So if you want to create a connection, an FTP connection, I just like need to select it here, give it a name, give the name of the host, the name of the schema, the login, the password, the port, and I click save. It's going to be, everything is going to be running there. I can integrate with Google Cloud SQL database, with Google Cloud SSH, with Google Cloud Data Preparation. So I can integrate with many services, even like services that like are from other public cloud providers that we all know about. Okay, so let me check if any questions before moving on. And I can start the quick lab. Okay, yeah. So now we are going to be like looking. You can start the quick lab items there. So basically, what we are seeing now is part of the quick labs, but I'm just like following it because it's obvious like what I'm doing here. But if you wanna follow and you don't have like your own Google Cloud account, here I'm using my own Google Cloud account. But on the quick labs, they are using like managed Google Cloud account. Basically, the steps I'm doing now, they are doing exactly the same ones on the Google Cloud. Yeah, so you can start and follow it, or you can wait by the end of the session. You can run it on your own to discover more what's happening. So I'm going to be following the step here on the quick labs where they are adding a new what we call new DAG to the bucket. So here you can see, if I open the DAGs folder here, you can see that I will only have one .py file. Now I need to add a new one. So how to add a new one? So basically I can either add it by clicking upload files and bring the file. Let me bring the file for you. Yeah. Okay, so sorry, just 1 minute. Let me look out for the link. Okay, here is it. So I'm going to be sharing with you this on the chat. I forgot about it. Okay, so you have this link. This link on GitHub is having like it's containing like many. Let me open it on the stream. Here, okay. So in this link, you have many DAGs, the many sample DAGs that Google is providing for you to test, like to test them on your code. To like maybe you can also be inspired by them or use them. So we can, like you can see here, that we have DAGs that they do Azure Blob Storage to GCS operator. That we have BigQuery notification DAGs. We have connections.py. We have data flow temperature or template operator. We have data process batch operator. We have the GKE operator. So we have DAGs for like literally anything that you want to do. We have also simple test DAG, which like this DAG is going to just like testing the imports of DAGs. Let's take one, let's say the Hadoop tutorial. Yeah. So let's use the Hadoop tutorial. It's the same one as like Quick Labs is using. So yeah, let's not go like over what Quick Labs is doing. So first of all, I'm going to download this file. Let me click on row. Let me copy the code. Let me open it on VS Code. Let's hit new file, Python file. Okay. So let's give it a name, which is Hadoop DAG, Hadoop DAG.py. Okay, so let's save it on our desktop. Save. Great. Now we go to our bucket. Where is our bucket? Yeah, so there is our folder supposed to contain our DAGs. So we just simply upload the file. can go directly to desktop, Hadoop DAG, open it. It's been uploaded. It's uploaded. So you can see here that I have it. So what I need to do is just like go over here, see on the DAGs list if I do have the new file or no. So I still don't have it. Let's refresh. Let's refresh. Yeah, so we still don't have it. Let's see what's the problem here. It's not public. Great. Yeah, okay, so it needs to be a Python, not Python script here. Yeah, that's the issue here. So we can do this, edit metadata. We can go here and we can just like put it as a Python. Save it, great. We can go now here and refresh. Okay, so I don't know what's the issue, to be honest, here. Okay, so if it doesn't work, if you have the same error on your side, there is another tip that we can go ahead and do it, is to open the Cloud Shell and upload it as like the way that QuickLab is doing, is just like by using the gsutil copy command. So we can like copy this here, go ahead, what is it? Go ahead here. We can continue here. Okay. Also, there is a step that we missed, but just let me make this happen here. Okay, so we go ahead to the bucket storage. This is the name of our bucket. So we copy it and we paste it here. Then we run. Otherwise, okay. So now we need to see the file come in. So we need to have 3 files now. Okay, Europe Central. Tags. Don't know what's happening here with the console also. So the tutorial. Okay, sorry. Yeah. So I need to go here to, what is it? So it's environment configuration. Yeah, so we go to DAX folder, this one. So we copy this one, then we paste it here. Okay, now we need to have 3 files. Let's refresh. Yeah, so now we have this one, which is like being uploaded using the GCS. But the step that we are missing, guys, here is the step of the environment variables. So we need to go to admin variables on Airflow here, and we define global variable of the DAG, of the cloud storage DAG. So we hit plus, add new record. Then here we give it the key as like I mentioned here. So the first one is the GCP project. GCP project is going to be the name of your project. So we go here, GCP project. The value is the name of my project, which is called my first project. So it's my first project. Then I hit save. Okay, same thing. I add another one, which contains the GCS bucket. So here is the key, GCS bucket. The value is going to be the name of the bucket, which is here. Here is the name of the bucket. We can take it directly from here. Paste it here, then save it. Then the third variable is the GCE zone, the Google Cloud Engine, the Google Composer Engine here region, which is Europe Central 2 for me, which is Europe Central 2 for me. Let me check this. Like by going here, yeah, it's Europe Central 2. Then we save. Okay, now everything is set up. Yeah. So there is an error with one DAG import, which is the Hadoop tutorial.py. Here we have an issue with the import. So let's see what's happening here. Okay, so the issue here that you can, as you can see here, is up for a try. The issue is that like we don't have the data pros service already set it up to be connected, but we can still view the graph here. So you can see here we have a graph that contains a list of tasks that we do have in our DAG. So our DAG, what does our DAG do? Is going to be creating a data pros cluster, running that data pros cluster, Hadoop inside that data pros cluster, then deleted the whole data pros cluster. It's a very simple one. We can see here on the code. You can see on the code that, as I was telling you, inside the operators module inside Airflow, we have data pros operator. So using this data pros operator, data pros is a service provided by GCP also for data processing. We are going to be using it to be connecting to data pros and installing Hadoop on it, then running Hadoop on it on some files, then deleting it. So basically, we create our DAG here. Then we create our first task, which using the data pros cluster create operator, because the data pros operator is the big class and it contains its own operators. So data pros cluster create operator is going to be creating the cluster for us. The data pros Hadoop operator is going to be running Hadoop commands for us. Then the data pros cluster delete operator is going to be deleting the whole cluster for us. Basically, it's very simple. The idea behind Airflow is that we go task by task. And as you can see here, the bit shift operators are telling us that we need to create the data pros cluster, then run that data pros Hadoop cluster, then delete it. So this is the order of the run of the clusters, or the run of the tasks, sorry. So task 1, then task 2, then task 3. If we shift between them, we are going to be having, if we make a shift between them, we're going to be having like the task, maybe task 3 here is going to be task 1. So everything, or the order of the run, depends on what we do define here. So here we define our DAG dependencies that Airflow is going to be running based on them. So let's go to the graph here. So you can see here that we have a failed status, because like the Airflow could not create the data pros cluster. If you want to know why and what's happening, either you can go to the logs of Airflow here. You can see that there is no key file for our hook. It's obvious, we didn't define even the hook for data pros. You can also go here to logs. You can see, let's go on DAGs. Let's go here. Let's go to this one. So you can see that here it's failed, and it's going to be showing you the logs another time here. So how to solve this failure here is by going on where did I go before? Did I show you here? Just like create a new connection of type data pros. So it's data. Basically Google data scale data prep, yeah. Then you give it name of the connection, you give it the host, etc., etc. Then when you connect with it, everything is going to be set it up for like running your job and being connected to your cloud project. Yes, so basically that was it. Let me check if there are any questions on the chat. I don't know if you have any questions, guys. If like you want us to make something more clear. Okay, so if no questions, I think we can say I can say goodbye. Inshallah, on the next session, we are going to be covering hands-on practice. Like we are going to be building a pipeline that involves basically Vertex AI service, so we can train a model and manage the output or the inference of that model using the Cloud Composer. It's going to be a little bit advanced, but more interesting. Yeah, so thank you very much for your attention, and see you inshallah on the next time.